We'll demonstrate a simple water level sensor suitable for a school or science project. It needs only 2 transistors, a resistor, and 2 wires. Water level sensors are often float valves or float switches, but if you need a sensor in tight spaces like a test tube or a beaker, or if you need to interface with a microcontroller, this circuit might be right for you. Now, I've been disappointed by water sensors like these. The problem was that the presence of water changed their voltage sense by only 0.4 volts. That's not enough to trigger a logic high or logic low on a digital input pin. A second problem is that the copper foil corrodes. Let's look at a better sensor device. The sensor is simply an insulated 24-gauge wire with about 1 centimeter stripped at the end. The second wire sends a logic level signal of 3 or 5 volts into the water. A very small current, just a few microamps, flows through the water between these 2 wire ends. Now we've attached those wires to this Adafruit Feather M0 board that's mounted on some headers. The LED is over here just to show the status of the sensor, wet or dry. The green wire comes from a logic output pin of the Feather board. The white wire connects to an input pin, and you'll want to use the built-in input pull-up resistor on the Feather or your Arduino board. So we'll place the 3-volt output in the water. The sensor wire is dry, so the LED is on. We'll dip the sensor and the LED is off. Dry, wet, dry, wet. When we run this circuit through the LT Spice simulator, we can show these 2 states. The transistors are configured as a Darlington pair. A small voltage at the base of Q1 enables current to flow to the base of Q2, where it's amplified even more. The gap between points A and B simulates the air gap between our 2 wires when the sensor is dry. The simulator tells us that virtually the entire supply voltage is output to our MCU pin, which sees this as a logic level high. The next screenshot simulates a sensor wet condition with the water's resistance symbolized by the 5 megohm resistor. And actually I've measured about 1 megohm in my tap water between the wires, so 5 megohms would be a worst case simulation. We see that the output has dropped to only 0.6 volts, which is easily low enough to be read as a logic level low. Now I should mention that this sensor does not work well in distilled water unless the wires are very close together, perhaps a couple of millimeters. But just asking that question, and why it doesn't work in isopropyl alcohol, might give you ideas for some experiments. In our final screenshot, our Arduino code defines our I/O ports, and it uses the input pull-up resistor by setting the sensor's pin mode as input pull-up. That's it. I hope you've enjoyed this and found it helpful.